one of the first things that comes up is, where does the IOTA fit in my network? And what we find is that for years, there's been capture to disk appliances that allow us to take traffic we see on the network and write it to disk at very high rates. These are incredibly powerful for being able to capture over long periods of time and analyze what's going on. One of the challenges that we run into is these devices, as powerful as they are also expensive. And in many cases, it just didn't make any sense to deploy these at our remote offices or have a device that we could send out to do an autonomous packet capture easily. And this is where the IOTA fit in. So the IOTA is a very small device. In fact, if we switch over here, I've got both our 1 gig and our 10 gig IOTAs right there. We're going to go through all the interfaces and so on those. But this small device is really powerful inside. And what it does is it's a device we can place in our network that fills that gap between using a tool like Wireshark on a laptop or using it with the Profitap to make sure we can get in line and capture all the packets, and a device that does capture to disk on a very large scale. It gives us those powerful back-in-time capabilities, while at the same time coming in at a price point that's pretty palatable, and it has an inline tap, so we can get in line with the packet. So not only do we have a packet capture device, but we have a tap in there as well. And we're going to see that the IOTA works really well for sending out, having somebody put in line, push the start button on it, capture the traffic, push the stop button, pack it back up and send it back to us. So it saves us a trip, and especially right now when we may not want or be able to get on that airplane to fly out there to see what's going on, this portability and autonomous capture capability is a really powerful feature. So let's go ahead and we're going to dig straight in and start taking a look at the interfaces that we have over here on the IOTA. So I'm going to flip over here to this camera. We're going to take a look at what we've got on our IOTA, and we're going to start right here with our 1 gig IOTA. Now, if we take a look at the front of the 1 gig IOTA, what we see is we see a couple of RJ45 ports right there. Now, this is port A and port B. These can be operated in 2 different modes. We can operate this in inline mode. All the traffic from A will be forwarded to B. All the traffic from B will be forwarded to A. So I can place this in line with a PC. I can place it in line with a wireless access point or a phone because this tap right here will pass PoE. Another nice feature of the 1 gig IOTA is that it will fail to wire. If we lose power on this IOTA, this will continue to pass packets between these 2 ports. So this means that if I put this IOTA in my network, I'm not putting a device in that is going to result in a network outage if it loses power. I love that feature because if for any reason we lost power on this, we want to know that it's going to continue to pass packets through there. The next thing we have is we've got a couple of status LEDs right there, and we have a button. And I absolutely love this button. What this button does is it start, stop, and reset. So what I can do is after I get the IOTA set up the way I want it, I could ship it out to a customer. And if they plug in the 2.5 amp, 12 volt power supply into this, or they plug it into PoE, and we're going to touch on that in just a minute, it's going to power up the IOTA. They can put it in line with their PC, and all they have to do is come over here and press that start button. And what we're going to see is that the capture LED is going to start flashing. Once that starts flashing, this is capturing packets and writing those packets to the 1 terabyte SSD that's in here. When they're done doing whatever it is that we want to capture, they just push that button again, and it's going to stop the capture. And if they push that button again for 10 seconds, it's going to shut this down cleanly. They can pull the power on it, and now they can put it back in the box and ship it back to me. So if you need to do remote captures, this is a very powerful way to get a capture device out there that's going to capture all the traffic, get in line, and capture those packets. Now, we turn this around, what we're going to see is on the back, we have our 12 volt, 2.5, or this is where we connect our 12 volt, 2.5 amp power supply. Now there is a model that has a little terminal strip right here, and that's the 24 volt to 48 volt model, and we can use that to power it. We've got our management port. Now our management port is how we're going to access this via the web interface. This also supports PoE. So you see that I've got this powered on, my LEDs are on, but this is running off of PoE. So I can have this plugged into a PoE connection. I don't even need to have this connection right there connected up. And we've got a couple of USB ports on there. Those are there for future use. Right now, the current software doesn't really use these, but we've got these two USB 3.0 ports back here for future use as new features come out. So on our 1 gig IOTA, I can put this in line with a 10 meg, 100 meg, or gigabit connection and tap in line and capture all the packets to this SSD drive that's in here. Now that SSD drive that's in there is encrypted using AES 256 encryption. So even if somebody got their hands on that drive, they're not going to be able to see the contents of that traffic that's in there. Now that 1 terabyte drive that's in the IOTA is shared with the operating system. And what we see is we get about 883 gigabytes worth of storage for the trace files. And when those trace files are written to that SSD drive, we can set it up so that they're written as a ring buffer. As soon as the drive fills up, it throws the oldest packets away and writes the newest packets to disk. So it's constantly capturing those packets. Now, if we come over here, we take a look at our 10 gig IOTA. Same push button, same LEDs, same ports back here. The big difference is with the 10 gig IOTA, we have two SFP plus cages here. We have A and B. Now, one of the big differences between this and the 1 gig IOTA is that this does not fail to wire because we have these SFPs. Once we lose power to the SFPs, they're not going to send any traffic or receive any traffic. So in this case, if I wanted to make this fault tolerant, what I would do is connect this up to a fiber tap. And that fiber tap would pass packets whether it had power or not, and then send the traffic over here. Now, as with the 1 gig, this can be run in inline mode. So I could put this in a fiber connection. We could also plug a copper SFP in here. So I could come in fiber and go out copper if I want. I can plug in single mode, multi-mode SFPs in here. Very flexible as far as the types of interfaces that we can put in there. In fact, I can even put a DAC cable in if I want. That's what I use here in the lab quite a bit. So in this case, this will not pass PoE, and it is not fail to wire like the 1 gig. But beyond that, we're able to put this in line and capture packets. Now, one of the questions that we oftentimes get is about what the capture rate is. And the published capture rate on the IOTA for the 10 gig model is 3.2 gigabits per second, or 5 million packets per second. So am I going to put this in line, full line rate, full duplex 10 gig? No. But I can get in there and get in on a 10 gig connection. Now, when we get to the section on configuring the IOTA, I'm going to show you how we can do things like packet slicing, filtering. We can do things to optimize both our disk space and the number of packets that the IOTA's having to go in and process. Okay. So one of the big things with that 10 gig is it's going to provide visibility into our 10 gig. And we'll look at some things that we can do there as far as maximizing those. Now, a few other things on that push button on the front. If I take and push that button and hold it for 20 seconds while I'm powering up the IOTA, that will do a factory reset on the IOTA. Now, when you do a factory reset, it resets everything and it puts it right back to the image that you received when you originally got it, which means it'll take it back to the original firmware version as well. So if you do a factory reset, you need to reinstall the latest version of the firmware. We're going to look at how we do that. If I take and press that button for 20 seconds while the unit's powered on, it's going to reset the password. And if I push that button for 10 seconds while the unit's powered on, it will do a clean shutdown. So these are a few things that I can do with that button in addition to using it for starting and stopping the IOTA. Okay. So now I want to connect my IOTA up to my network. So what are the different models here? Well, the different models for connecting our IOTA up to the network are one, inline. So I mentioned in both the 1 gig and the 10 gig model, we can place this in line between the network and some device, between two switches, pretty much anywhere where we're going to have Ethernet traffic passing. So this is where I need to ask myself, when I go in to set up the IOTA, when I go in to start doing my capture, what is it I want to do? Now, we can plug the IOTA into packet brokers. We can plug it into taps. We can plug it into a span port of a switch. In fact, if I have two different switches I wanted to monitor, I could put this in what's called span mode. Now, span mode is where we capture on A and B at the same time, but we don't forward the packets between them. This allows me to capture in two different locations. I've done some videos on how we can capture on each side of a firewall using this and measure the latency of that firewall by looking at the delta time between those packets. So you need to decide before you put the IOTA in, do I want to get in the path of the packets using the integrated tap, or do I want to plug this into a span port, a packet broker, or some other device that's already installed in the network? And here's what I want you to think about. When you're building out your network, go ahead and put some fault-tolerant taps in ahead of time. That way, when you bring your IOTA in to connect it up, you don't have to break the link to connect the IOTA. You take port A on the IOTA, plug it into port A of the tap, port B of the IOTA into port B of the tap, and now you're in the path of the packets capturing. But having that flexibility of being in the path of those packets is fantastic. So let's say we want to send the IOTA out to a remote location and have somebody do a capture. What we're going to do is we're going to decide, do we want to do span mode or inline mode? We're going to configure the IOTA for that mode. We're then going to shut the IOTA down. We're going to put it in the box. We're going to ship it out to the remote site. We're going to have the person at the remote site place the IOTA in line. That's what we chose to do. They're going to power it up. And then as soon as those two lights are solid, they're going to hit capture button. And as soon as they hit that capture button, that capture LED is going to start flashing. And in that case, once that starts flashing, they are capturing. So then they can start doing whatever they need to do. When they're done, push capture again. That is going to stop the capture, push and hold capture for 10 seconds. That's going to shut the IOTA down. They power it down, put it back in the box, and send it off. Okay. All right. So there we go. That's how, those are some of the things that we can look at for capturing that in line. Okay. Now, the next thing after we get this connected up is we need to go in and access the IOTA. And I know what you're thinking. You're tired of looking at me. Now you want to look at the IOTA. So let's go ahead and we're going to do that. Now, when it comes to accessing the IOTA is locked down, and there is only one way we can access the IOTA, and that is through a web browser. So what we're going to do is we're going to HTTPS into port 3000 of the IOTA's IP address. So how do we know what IP address the IOTA got? Well, there's a couple of ways we can locate the IOTA on the network. The way I typically do it is after I connect the IOTA up, I will go out to my DHCP server, and I will find the MAC address for the IOTA, and I'll find the IP address it received. So now I know what IP address to use. Now, because the IOTA uses TCP port 3000, we could scan the network and look for what devices have TCP port 3000 open. What I recommend you do is after you find out which IP address it got on your DHCP server, set up a DHCP reservation. Now that management MAC address won't change. So if you're going to send this out to a remote location, you know what that MAC address is after you've seen it get an IP, set up a reservation on that remote network. Then when you ship that IOTA out and they plug it in, you know what IP address it's going to get. So in that case, we can do that. Now there is a fallback IP address on it. And that fallback address is 169.254.1.1. So if I just took and plugged a cable in between my computer and the IOTA, I could use that fallback address to access it, even if I don't have a DHCP server. Now, what we're going to find is that after we get that all configured up, we are going to bring up our web browser. We're going to connect to HTTPS, the IP address of the IOTA, port 3000, and we're going to get a window that comes up and asks us for a user ID and password. The default user ID and password are admin and admin. Now, once you enter those, the IOTA is going to come up and ask you for a new password. So we're going to put that password in, and now we're all set to go to access that IOTA. So let's go in, and I'm going to come in here, and we're going to share our IOTA, and we're going to start taking a look at some of the different settings on there that we can do. Let me just take a quick look. We'll take just a moment here. I'm going to look at some of the questions real quick. All right. So let's come in. I'm going to go ahead and share the screen on the IOTA. So here's the screen that we get when we log into the IOTA. Okay. So we've got our IOTA connected up. We've set up the management interface. We've got the IP address. So now we're going to come in and log in. Now, I've logged into this one before. So I already have changed the address here. I don't want that. All right. So we're going to log into our IOTA. Now, the first thing that happens here is that we get our home dashboard. Now, before I continue on, what I'm going to do is come over here and I'm going to plug in a cable into port A of my IOTA. Now, I'm going to run this IOTA in span mode. We'll go in and take a look at how we set that up. But I've got that connected up to my network so we can collect some traffic on there. So one of the things that I'll do is I'll come in here to my time settings and make sure that my time looks good. I can come in here and configure up my NTP configuration. So I can set my time and date and tie that in with NTP. This is very useful when we're going in and correlating captures that we've done with log files. Come over here to my network configuration. Now, right now, the IOTA is set up for DHCP. I could come in here and change that to a static address if I wanted to. I tend to like to use DHCP with a reservation. That way, if I take the IOTA somewhere else, I don't have a static address on there. But this is going to depend on how you want to configure the IOTA for your environment. I can come in and I can set up what access we're going to have, whether local access, remote access to it. Also, I can configure zero tier. Now, zero tier is a way that I can access the IOTA through firewalls. If I go out and configure a zero tier account, I get a network ID. When I put that network ID in here, what the IOTA will do is it will reach out and establish a connection with zero tier. For my PC, I establish a connection with zero tier and I create my own little private WAN network, my own little software-defined network out there where now I can access the IOTA even if it's at a remote location where I can't VPN directly into that location. So this is really nice if you're going to be sending your IOTA out to a remote site and you want to be able to log into it. As soon as they power it up, it'll go out and connect to zero tier, and then we can remote into that IOTA. Okay. System updates. Here is where we go to update our IOTA. So the IOTA is constantly going out and checking to see if there's updates. If there are updates, it will show us the current version that we are at, and we can come in and we can take a look at which version we have, what version is available. If I was not at the current version, I could come in here and click on update and update this. It will download the new version, it'll install it, and it will restart. So the update process is really smooth, and it just keeps getting better with each one of the different versions that comes out. So to do a system update, we just need to come out here to our IOTA settings, go to system updates, and click on update. It's as easy as that. So all these updates are done over the air. Lastly, in here we have system control and logs. If for any reason you were to contact the Profitap help desk and get some help, they may ask you to come out here and download the logs if necessary. If you need to do that, this is where those are. So this gets us through how we can go in and make some of the settings. So when we first put the IOTA on our network, we can log in, we can assign a static IP address, we can set up our NTP server that we want to synchronize with, and we can check and make sure there's updates. So if you don't have your IOTA already, when you do get it, make sure you go out and check for updates and see if there's any out there. All right, so now that I've got my settings done, I'm going to come over here to my capture, and I go to my interface configuration. Now, in my interface configuration, this is where I can configure my capture interfaces. So in this case, right here, I can see that port A is up, the link is up, and here I can change some settings on there. I could change my speed, duplex, etc. Not something that I typically go in and change, but again, if you need to change these parameters for your environment, you can go in and do so. I could come in and take a look at my port status and see, is the port up? What do I see as far as the other end of that status? Capture features. This is where I can turn off and on some of the features are what I'm going to do when I'm capturing. So here I could come in and disable one of the ports. So let's say I didn't want to see any traffic from port B, but it's already connected. I could go in and disable port B so that traffic isn't being written to disk. I could also turn on packet slicing here. And packet slicing allows me to conserve disk space. So if I have packet slicing turned on, what's going to happen is, in this case, I'm only going to capture the first 128 bytes of each packet. So this is nice if all I'm interested in is the flows, but I'm not interested in all the data in the packets. Now keep in mind that if we need that data, it's not being written to disk. We're not going to be able to go back out and get that data. And then lastly, we have our firmware. So when we do a software update, it's good to check our hardware firmware version and compare that with the hardware firmware version that we have right here. So that firmware gets downloaded when we do our update. So if you do an update, come out here and make sure that your firmware is updated as well. We may need to flash that hardware firmware. Now, while we're on this screen, I'm going to jump over here to my 10 gig IOTA. We're going to go to that same screen. I just want to show you on the 10 gig IOTA a couple of the differences here. And that is, well, one of the things that's the same, and I hadn't touched on this yet, is our span mode. I keep talking about span mode or inline mode. Inline mode will pass packets from port A to port B and from port B to port A. It's designed to be put in line with the device. Span mode captures on A and captures on B and writes both of them to the drive. So if this box is checked, we're going to take everything that comes in on A and everything that comes in on B and write it to disk, but we won't pass any packets between the two. If this is unchecked, it is in inline mode, and we will pass packets between those, and that's designed to be put in between a device and the rest of the network. Okay. Now, on the 10 gig model, there's an important little checkbox or a drop-down box right here, and that's our firmware mode. Now, I mentioned when I was talking about the overview of this, that the 10 gig model supports both 10 gig and 1 gig SFPs. But if we're going to use it with 1 gig, we need to make sure we come into port control and select the 1 gig firmware. If we're going to use it with 10 gig, we need to come in and select the 10 gig firmware. So this determines what speed that port's going to be running at. So just because we plugged it in and it auto-detected that there was a 1 gig SFP in there doesn't mean it's going to work with that SFP until we set it to the correct speed. So the firmware here needs to match the speed of the SFP that you put in. Now, many of our capture features look the same here. We do get our SFP information. We do have our firmware information right here. So I can come down. Actually, I see I need to upgrade my firmware. So in this case, I could select that and say flash firmware. And what that's going to do, we're going to stop capturing. This is a good opportunity for us just to see how we flash that firmware. I can come into firmware, and we're going to say select that. So 319, I'll say flash firmware. We're going to say OK. We'll get this. There we go. So now I've gone in, I'm updating that firmware in there, so it's going to update that. Well, that's updating. Let's come over here and take a look at our filters. And this is one of the big differences between the 10 gig and the 1 gig IOTA models. And that is we can do capture filters with the 10 gig model. So I can come in and check what it is I want to capture. Now, I mentioned before, the 10 gig will capture up to 3.2 gigabits per second or 5 million packets per second. So in this case, we may want to filter out some of the traffic that we see. And by filtering this traffic out, we can reduce the data rate that's actually getting to the disk, and we're able to write that and not lose any packets. So using the filters in here is a really good way to go in and do that. Okay, so we've got that updating, so it's flashing that firmware, and away we go. So let's switch back over here to our 1 gig IOTA, and we're going to look at starting our capture. So on my 1 gig, I'll come into my capture control, and I've got my interface right here. Now, when you first set up if you do a factory reset, you're not going to see this interface right here. What we're going to need to do is come up here to this drop down, drop that down, select the interface, and click the Add button. And once we do that, we're going to see that we have our interface right here. Now, I could come in and edit that interface. I can give it a name. And right here, we see this checkbox that says Keep Files. If that is unchecked, I am going to capture the traffic. I'm going to analyze the traffic. And once I get done analyzing the traffic, I throw the trace file away. If I check on Keep Files, then I will keep that trace file, and I can go back and grab those packets. So this is where we need to decide, do we want to keep all the data, or do we just want to analyze the conversations and be able to see what's going on with that traffic? But that's what our Keep Files gives us. Now I'm going to keep the files because I want to be able to get all the packets. I want to see what's going across the wire. Now here we have our DNS resolution. What the IOTA is doing is it is monitoring DNS queries as they're going across, and it is keeping track of what name came back for each IP address, or if we did a pointer record, or if we did an A record, what IP came back for what name. So it's going to correlate that information. Now, if I don't have the management port connected up, I'm using this in autonomous mode, it is going to base this DNS resolution on the DNS queries it sees go by. If the management port is connected, it will actively go out and resolve names and IPs to addresses. So if I have a MAC IP address, it can resolve it to a name. If I have a name resolved to an IP, it's going to go out and do those resolutions. So if we're connected to the network via the management port, it is actively resolving DNS as well as passively resolving DNS. So our indexing. This is writing the information to an Elasticsearch database. Here is an important concept when it comes to the IOTA. To ensure that we see no packet loss as we're going from one file to the next, what the IOTA does is it captures and writes to file. Now, after 30 seconds, it will close that file, or if the file gets to 4 gigabytes, it'll close that file and move to the next file. Keep capturing, move to the next file, move to the next file. After that 30 seconds, it will take that file and it will analyze it and put it into the Elasticsearch database. So we see a message down here at the bottom that says that files will be available only after the first 30 seconds of capture. So we're on our screen where we're showing the flows, we're showing the traffic. That is about 30 seconds behind what's actually happening on the wire, because we want to get those packets written to disk first. Then we're going to go in and analyze them. Then we're going to display it out there on the graph. So that's why when you hit start capture, if you don't see something immediately, don't panic. We want to wait about 30 seconds for that first file to get written. So what I'm going to do is I'm going to come in and I am going to hit start capture. So it is going to start capturing packets. Now, what I look for right here is written to file. I am going to go out and ensure that data is being written to a file. This is how I validate that I am successfully going in and capturing those packets and writing them to disk. Now I know that I've got data coming into my input port. It's being written to disk, and what we're going to see is after about 30 seconds, we're going to see files written increment to 1. And it's going to write that first file. It's going to analyze it. There we go. We got it written. It's going to analyze that, and now we can go in and start taking a look at that. Okay. So after you start a capture, always make sure that you come back in and check and make sure that that's being written to file. And then that way we know that we're set to go. So we've gotten quite a ways. We've gotten this hooked up, gotten our capture started, gotten our interface configured properly. So let's come up here to our home dashboard and start seeing what's going on. So this is our home dashboard. This is when we log in, this is where we start. And what we can do is the first thing we want to take a look at is our time frame. And there's a number of different ways that we can select the time frame. The easiest way is to come up here and click on one of our predefined time frames. I could say, you know what, show me the last 5 minutes of traffic to go across the network. So what it's going to do is it's going to show me the last 5 minutes of traffic we've seen show up on our capture ports. And again, remember, we're about 30 seconds behind what's actually coming in, but it shows us our traffic. So we can see how much traffic's come through, packets. So we can see our packets going across here, and we see our addresses. We see our clients and our servers down here. It shows us for this time frame how much traffic have we captured, how many packets, and how many unique flows, as well as the various protocols that we've seen in there. Now, it could be that you're troubleshooting a problem where you need to go back to a log and find that particular time. So what I'm going to do is I'm going to jump over here to my 10 gig IOTA. Okay. And we're going to start our capture again. Here we go. This is where I need to add my interface. We're going to go ahead and start that 10 gig IOTA again. But in this case, I could come back, and I've been capturing for a while. I could come into the 10 gig IOTA and I could put in a date and time. So I could say custom time range. And I could go back in time. So I could say, you know what? I want to go back to June 10th. And I'm interested in June 10th. And I could put in a date and time and be able to grab that traffic for that time period and hit apply. Okay? I don't have traffic back that far. Now, the other way, we've got our predefined time range. We can choose that. The third way is to come in and select a time range with our mouse. So I can highlight that time and come in here, select that, and it's going to show me what happened during that time period. So if I see that little spike right there and I want to know who was talking during that time period, I could come in, highlight that, and it's going to show me who was talking. I could see who the top talkers are right here for that particular conversation. So this starts giving me an idea of what's going on. If I want to go back out, I can just come up here. I could say, hey, I want to go back out to 15 minutes. Somebody calls in and said, hey, you know, what's been going on over the last week? I could say, show me the last 7 days. Here is one of the important things we want to remember. When we start going in and grabbing packets, we are going to select that traffic that we're going to filter from this time period. So if you choose 7 days, the IOTA needs to grind through 7 days worth of trace files to pull that information out. So it could take a while, but that gives you the ability to go back, instead of filtering, go back in and take a look at what happened over the last 7 days. So we could choose a more reasonable time frame right here. Click on that. Now, right now we are set to do a manual refresh on the dashboard. So when I come up and click on refresh right here, it's going to refresh. I can drop this down and I could set that to 5 seconds. So if I'm going to have this up on my screen and I want to keep an eye on what's going on with my network, I could come in here and I could set that refresh to 5 seconds. Every 5 seconds, it's going to update that screen and I can see what's happening. So if somebody did a big file transfer and caused some issues on my network or something, I could come in here and take a look at that. So it shows me, for the last 5 minutes, we've seen about 39 meg go across the network. With our dashboards, we could come in, there's a little arrow next to that. We could do various things as far as our views, editing, etc. One of the easiest things we can do is come down here to export CSV. If I want to grab those servers right there and the amount of data that they've sent across, I could come in, click on that little down arrow, and I could export that CSV. So we're seeing a lot of information here. So the next thing that we may want to do is go in and filter down on that information. So let's take a look at dashboard filtering. What are some of the easy filters that we can create from our dashboard? One of the easiest filters that we can do is we can come in and we can hover over a device. So I'm going to go to this screen, and as I go over each device, what you see is you're going to see a little magnifying glass show up. We've got a filter for value and an exclude, filter out value. So let's say I just wanted to see the information for this device right here. I can click on filter for value. What it does is it puts a filter up here at the top that has now been applied to my display. There are 3 different filters that we see up at the top. So I just want to touch on the importance and where each one of those fits in. And I'll give examples of each of these. But right here, we have our custom search. Our custom search is a display filter. The custom search affects the information that is displayed, but it does not affect the information that is downloaded when we download a PCAP file. So I could have a custom search that drills in on a very specific thing. And when I click on download PCAP, I get 40 megabytes worth of traffic. That's because my custom search allows me to change what's displayed here, but it does not impact the download PCAP. Our filter in the middle changes our display and changes the download PCAP. So if I download this right now, it will only download this information for this IP address. So that filter right there is a really good way to filter down on a specific device. Then we have our Berkeley packet filter window right here. This affects the download only. So I can come in here and put in a filter, and when I go to download, that filter will be applied as I'm downloading, but it does not affect the display. So depending on what we are trying to get out of here, we can put these various filters in. So in this case, I filtered on an IP address. So I'm sure you're thinking, well, Mike, what other filters are available? Well, if we come in here to our filters right here, and I click on this, this shows me all the different filters that are available. So I could come in, and one of the ones I really like is I can say L7 protocol name. So now I can filter on a protocol name. And what this does is this is looking for about 200 different protocols, and it's going to come in and identify those. So I could say, you know what, I'm interested in SSL Microsoft 365. So this isn't going just by port, but it's going by what server it's talking to. It's going by the characteristics of that traffic. So I could click on that, and we could open up our time window right here, and it's going to show us what traffic we've seen for SSL Office 365. So one of the things I really like about our filters in here is that we can come in and we can select that based on values that are shown in here. So for instance, if I was interested in my PPTP, let's see, am I getting PPTP in here? Yeah, we could say, oh, MQTT. This is a messaging server. And so now what we see is we see some devices using MQTT. These are the various Wi-Fi outlets I have here in the office. They're going out and communicating with the servers. Now, this is a great time to go in and take a look at another dashboard. Now, when we switch dashboards, there's two different ways we can do it. One is I could come over here to my dashboards and click on Manage and jump to a dashboard. But you know what that's going to do? That's going to wipe out this filter up here. So the best way to switch dashboards and not lose this filter that we've created is to come over here to Go To, and then we can go to our dashboard from here. So when I do that, it retains the filters that I put in. So what we find is I still have my MQTT server or filter. So over here, I can see my server locations. So now it starts showing me where those servers are. So if I want to know who I'm talking to and where they're located, this has a geo IP database that's stored on the IOTA. It doesn't need to go out to the internet to get this information. It's going to come back and show us where those IP addresses show up in the geo IP database. So now I can get an idea of where the clients and the servers are. Okay. I could go back. I could come up here and I could say Go To. I could come back to my home screen. Let's see, there we go. Come back to my home screen, I haven't lost the filter. Now let's say that that's not enough. I want to get further into MQTT. I could come down here and I could select a device. I could say filter on this value. Now it does an AND. Now, right now, the only choice we have here is AND, but we can AND these filters together to keep drilling further and further in. Here is one of the big concepts with the IOTA that I want you to see, and that is this isn't just writing to disk and we download all the traffic. We are doing a tremendous amount of analysis right here using these dashboards to zero in on those packets that we're interested in. So now I could come in and I could download that traffic. I could either say download PCAP, or I could click on this host right here. What it's going to do is it's going to download that traffic to my disk, and I could go in and open that up with my protocol analyzer. So I've grabbed that traffic out, and that traffic could have been from weeks ago, because this gives me the ability to go back in time and see what's going on. Okay. So many different ways to create a filter. Now I'm going to come up and I'm going to click on Clear Filters. And I clear all that out. We're going to take a look at the last 30 minutes. So my search window up here. My search window gives me a way that I could come in and I could say, I want to look for that SSL.Facebook. Let's give that a try. Oh, there we go. So I put in the protocol name I'm looking for, and it puts that in. I could put in an IP address, 50. Or let's put in 75.75.75.75, the Comcast DNS server. So I can throw that in there. The custom search provides a very easy way for me to change my display. Now, this does not affect my downloaded packets, but it does change my display and allow me to quickly zoom in and see what's going on in here. We can even come in and take our filters, and I could say IP dest : 50.1 or 94.62.33 and L4 dest port : 23. So what does that give me? That gives me everybody that's trying to telnet into my network. So now I'm going to hit enter so I can see those devices that have tried telnetting into my network. Now this allows me to put an OR up here so I can do a little ORing. Now, like I showed you before, we can jump to another dashboard using GoTo and we don't lose that filter. So I say go to hosts. Still has my filter up there, but now what it's doing is it's going to show me where those clients are. So now if I drill in here, I can see that I've got a client coming in from down here. I could zoom out. We've got some clients coming in from over here, right there. So we can see where those clients are coming from. Okay. So now, using our custom filters and using our other dashboards, we can start getting an idea of what's going on. So I can go back out to my home dashboard. We can really start getting in and doing some troubleshooting if we use filters like retransmissions. So I can say retrans. I could say client retransmissions. I could say greater than. And we could say 5. So this is going to show me all those connections where I saw client retransmissions greater than 5. So now I could start seeing maybe where I'm seeing packet loss occurring in here. I could drop that down. We could say, how about, whoa, client transmissions greater than 158. So now we could really start getting an idea of where we have some issues out there, what's going on. So there's a whole slew of dashboards in here. In fact, if we come over, we take a look at our dashboards. We can come in, I can click on my dashboards, I go to manage, and from here, we can come in here and manage our dashboards. We can create playlists that will go through the dashboards. We can create new dashboards. We can import dashboards that have been given to us. Now, if creating a dashboard's outside the scope of this training right now, but let's say that I created a dashboard, I could send you that dashboard and you could import it and use it on your IOTA. Now, one of the questions that I know came in was around importing a PCAP file. So let's go in and let's take a look at how we can come in here and import a PCAP. So I've captured traffic elsewhere on my network. And I want to take advantage of the power of the IOTA to analyze that traffic. So what we're going to do is we're going to take that packet capture that we captured at another time on another device and bring that into the IOTA. So the first thing I'm going to do when I go to bring in a capture is I'm going to come into capture control. And right now we can't capture live and import a trace file at the same time. So what I'm going to do is come in and stop my capture. Then I'm going to come in and I am going to import my PCAP file. One of the things I always do when I import my PCAP file is I give it a different session keyword. This can be used as a filter to quickly filter down on just that traffic. So I'm going to call this, we'll call it my trace 1. Okay. And I'm going to select a file. So I'll come out here and I'm going to grab this trace file right here. And I am going to start analysis. So our analysis, it's going through and analyzing that trace file. It's grabbing all those flows and it's bringing that into the IOTA. Now, I could come back out to my capture control. I could start my live capture. So now I'm capturing. We're going to come back out to our home dashboard. So now I want to find that traffic I just imported. So the easiest way is I'm going to add a filter. I'm going to say session keyword. I'm going to say my trace 1. Now we don't see it because here's the thing. The IOTA uses the timestamps when the trace was captured. So that trace wasn't captured in the last 3 hours. So what I can do is say, show me the last 7 days, last 30 days. Oh, there it is. There's our capture. So now I can start zooming in on that time frame when that trace was captured. And now I can use all of my different dashboards to analyze that. So if I come in based on this session keyword, I could say go to, and I could say I want to see my TCP troubleshooting. So it's going to start showing me how many ACKs I have, fins, what's going on in there. I could take a look at what my round trip times are. I could look for things like server congestion. So this allows me to use the IOTA to analyze that trace file. That trace file could have been captured on a router, on a switch. Well, not necessarily on a switch. I've got VoIP phones that have the ability to do a packet capture. So I could use those to capture the packets and take a look. So this training today intended to get you started with the IOTA. So we looked at how do we connect it into our network? How do we connect to the IOTA? How do we log in? How do we set up our capture and get that capture going? How do we start coming in and taking a look at our dashboards, grabbing those trace files? So I can use my download PCAP, or I can come in and I can filter on something. So notice that even once we start drilling down in here, we could start taking a look at our filter. So we could say, we've got this device right there, server IP. Okay, we could see where do we see a lot of retransmissions. This device right there, 40% retransmissions, that's crazy. So I could click on that device. I could click on filter right there. And now I'm filtering down on that device. So we could then come in, I could say download PCAP. It downloads that trace. Now I could come in, start analyzing the trace, trying to get an idea of why am I seeing those retransmissions. So we have a number of troubleshooting dashboards. The great thing with the IOTA, as new versions come out, we can see new dashboards come out, new analysis being performed, new protocols being analyzed. So it is constantly being updated with new features. All right, so what I'm going to do is there's been a number of questions. I'm going to go through and let's just run through some of these questions and take a look here. So let's see. One of the questions, about do we lose any packets when we're writing to disk? No, it's writing it to buffer. So that's going to help us keep from dropping that. If we put copper SFPs in the cages, then would it fail to wire? No, because with the SFPs, as soon as the IOTA loses power, the SFP loses power, and we can't continue to capture. So that's why I had brought up that idea of using a tap. So if we have a tap that supports fail to wire, then we can connect the IOTA to that. Now, we don't need that with the 1 gig IOTA. The 1 gig IOTA will fail to wire. We're not going to lose a connection if it loses power. But with those SFP cages, there's just no way to do the fail to wire with that. Okay. So again, on the 3 gig capture rate, on the 10 gig IOTA, that's the way it is right now. And this is, again, kind of the gap that IOTA is filling. I've got boxes in back I've built over the years for doing exactly what the IOTA is doing, but the IOTA does it so much better. And that is a small compact device that gives us that visibility out there. And with the 10 gig, we can connect into a 10 gig interface. And oftentimes, we're not running at full line rate 10 gig. In fact, one of the really cool things we can do with the IOTA is connect it to something like a packet broker. We can use that packet broker to narrow down the traffic that we're looking for and then send it out to the IOTA so we can capture it and do that analysis. Because somebody in the last webinar asked how long it would capture at full line rate 10 gig. I didn't do the math in between, but we're going to burn through that 883 gigabytes worth of disk pretty quick if we were capturing at the full 3 gigabits per second. Okay. All right. So a question, when is the fallback IP address used? That's if there's not a DHCP server out there. So if I plugged in and I was just plugged into a switch and all I wanted to do was configure up the IOTA before I sent it out, I could plug a cable right into my PC and connect to the 169.254.1.1 address on the IOTA. But I would need to have a corresponding address on my machine. Can the IOTA pick up all traffic? Yes. I mean, it is looking, if it's an Ethernet frame, if it's a well-formed or even one with an FCS error at the end or a CRC error, it's going to grab that as well. Does the IOTA require a capture to be running to analyze it? If I'm going to, let's see. So what happens, we see that as we're capturing, we're analyzing those trace files and then putting that metadata into Elasticsearch. And so we could end up in a situation where we still have the data out there in the database, but the trace files are gone. Okay. And yes, I showed how we can import a PCAP file. Okay. All right. So a couple more questions. All right. So we're at the top of the hour. I'd like to thank everyone for joining us today. This webinar is being recorded and it will be uploaded and a link will be sent out so you can come back. And if you're not tired of watching me already, then you can go back in, watch me over and over again. So I'd like to thank you for joining on today, and I hope you found this information useful, and I look forward to seeing you in a future webinar.